All right, let's do surface area examples. So we are looking first to find the surface area of a solid formed by rotating a semicircle with a radius of 2 from 0 to 2 and 2 to 0. So that's interesting. It looks like a first quadrant only. So let's take a look at this graph just so we make sure. This is the semicircle. This is from -2 to 2. So the point 0,2 is right here. I'm sorry, the point 0,2 is here, the point 20 is here. So it looks like we're just doing this quarter circle and we're rotating it around the x-axis. So to do that, we're going to have a 2 pi out in front. Our x-axis limits of integration are 0 and 2. And then what we need is f of x, which is the square root of 4 minus x squared. And then we're going to need the 1 plus f prime of x squared, the distance formula, dx. So in order to come up with that, I need f prime. So I'm going to go ahead and differentiate over here that f prime is 1/2 times 4 minus x squared to the -1/2, and then times, 4 minus x squared here, and then times the derivative of -x squared, which is -2x. And when I clean that all up, and I'll put that over in here, I'm going to have, first of all, this 1/2 and this 2 go away. So I have -x divided by 4 minus x squared, and this was under a square root, but keep in mind, let me color coordinate this, please. Close out with the green here, and I'm squaring that. So there's a lot of work that I can do actually by hand to get this integral. So I'll have 2 pi, and I'll have from 0 to 2, and I'll take the 4 minus x squared here, and then let me kind of work on what's going on underneath this radical. I'm going to do that over here. The underneath the radical is 1 plus x squared over 4 minus x squared. Okay, so if I get a common denominator, I'll have 4 minus x squared plus x squared over 4 minus x squared. And as you can see, the plus or minus x squareds will cancel. So coming back over here, underneath the radical, I have 4 in the numerator and 4 minus x squared in the denominator. Well, that's helpful because I have this denominator of the square root of 4 minus x squared, and I have this 4 minus x squared. Those will now cancel. And of course, the square root of 4 is 2. So I have 4 pi times the integral from 0 to 2 of just 1 dx. Of course, 1 integrates to x, evaluate from 0 to 2, and I get a surface area of 8 pi. All right, let's do another one. Let's go instead around the y-axis. So when we revolve around the y-axis, we need limits of integration are still, well, actually, I'm not going to go there on the limits of integration yet. What we need, we have to replace the f of x here with f of y. We have to replace the f prime of x with f prime of y. Okay, so let's find the surface area that when we rotate y equals x squared from the point 1, 1 to the point 2, 4, but around the y-axis. We have two different approaches to this problem. We know that f of y equals x. So let me write that down for you. F of y equals x. So right here where we have f of y, we're allowed to just write in x. So let's do that. We'll have 2 pi, and then instead of f of y, we put in x. And then since f of x equals x squared, we can say that f prime of x equals 2x. And if you recall from when we learned about arc length is arc length is arc length, no matter whether you look at it from the x-axis standpoint or the y-axis standpoint. So to find arc length, I'm allowed to just say 1 plus f prime squared. So 2x all squared, and then dx. And now since I'm, with respect to x on everything, I'm going to use my x limits of integration of 1 to 2. Okay? Now, in order to integrate this, I'm going to need to use u sub. I have u equals 1 plus 4x squared. I have du equals 8x. And I can divide that by 8 here. and I just have x dx. So what I'm going to do is I have a 2 pi out in front, and then divided by 8 from this divide by 8 over here. And then in my integrand, I'm going to have x dx is here, and then I'm just going to have rad u. So u to the 1/2. And notice I'm not putting in limits of integration because they would be wrong if I used 1 to 2 because that's in terms of x. So I'm going to wait until I convert back to x values in order to re-bring in my limits. So I have pi over 4, and then u to the 1/2 goes to 2/3 u to the 3/2 from, oh, not going to do that yet. I almost forgot what I was doing. Now let's put this back in terms of x. So I have pi over 6, and then the u was 1 plus 4x squared, and then that's to the 3/2. Now I'm going to take that from 1 to 2. So when I work that out, that's a 2 right there, by the way. When I work that out, I get pi over 6, and then I'm going to have a 2 going in here, so I have 17 to the 3/2, and then a 1 going in there, so minus 5 to the 3/2. And I could put that in my calculator to get an estimated answer, but this is good enough. We can leave it like this. Okay, I'm going to stay on the same video here because there's a second approach to doing the same problem, and you guessed it, it's in terms of y. So I converted it first to be back in terms of x, but let's try this again in terms of y. So we were given y equals x squared, but I could just as easily convert that and have x equals rad y. And then f prime of y would be 1 over 2 rad y. So I could do my surface area using the y values, and let me go back and show you that the y values of the points of intersection were 1 and 4. So that means I can integrate from 1 to 4, and I need 2 pi, and then I need f of y, which is rad y, and then, whoops, need a radical there, and then under my radical for arc length, I need 1 plus f prime of y squared dy. Okay, so now I can clean this up. I can do this by hand again. So I have 0 to 1, I'm sorry, 1 to 4 here, rad y, and then under the radical, I'm going to have 1 plus 1 over 4y, and of course dy. And I need a common denominator under my radical, so I have 2 pi, and then I have 1 to 4 rad y, and then I will have, under here I have 4y plus 1 over 4y. Okay, now I'm going to rewrite this denominator here, taking it out of the radical as 2 rad y. Okay, then my rad y's will cancel and my 2's cancel. So I'm going to be left with pi times the integral of 1 to 4 square root of 4y plus 1 dy. Now I can do this as a fairly easy integration problem. 4y plus 1 goes up a degree to the 3/2. My pi out in front. Now I need a 2/3 to fix the power rule. So I go up to 3/2 and multiply by its reciprocal 2/3. Then don't forget you have to divide by 4 to undo the chain rule. And I'm going to evaluate that from 1 to 4. I think it might be best if I clean it up a bit first. I'm going to get 2 pi over 12, so that's pi over 6. And then if I plug in a 4, I get 17 to the 3/2. And if I plug in a 1, I get 5 to the 3/2. And look at that. It's the exact same answer I got when I did this the other way. So basically you can use or find surface area in terms of either x or in terms of y, and you'll get the same result.